So in our previous classes, we have looked at mass balance for non-reactive system, where we did examples for mass balance for single unit and multiple unit. So for today, we're going to be continuing our next topic, which is going to be mass balance for reactive system. Meaning that here we'll be looking at examples of how we do mass balance when we have chemical reactions. Okay? Before we continue to do the mass balance, I think that it is good if we talk about, first of all, is about stoichiometry. So basically stoichiometrics, balancing chemical equations, how to convert from mole to mass, mass to mole. I think you have learned all this in your high school, and I know that Dr. Hani has also touched on this thing, but this is just as an exercise, as a revision for everybody, including me. So today we're going to be looking at our first topic, which is going to be on stoichiometry. So stoichiometry is basically a principle which provides relationship between reactants and or product in a chemical reaction to determine the desired quantitative data. Okay, so we use stoichiometry to find the relation between our reactant and product and to find the desired quantitative data. Okay, it also tells us about the substance reacting and the product produced. So here is an example of a chemical reaction equation where you have on the left hand side here you have your reactant, and on the right hand side here you have your product. So I'm sure that you know that this is AQ, meaning is aqueous, S is solid, and G here stands for gas. So this is just for a refresher. So you have here sulfuric acid plus with sodium will get you sodium sulfate plus hydrogen gas. So this is a chemical equation, and then for every chemical equation you'll have a stoichiometric coefficient. Okay, coefficient or the number in front of the chemical formula of the substance tells us about the mole ratio among the substance that reacted and product. So if you see here, if there is no number in front of your sulfuric acid, meaning that is 1. The stoichiometric coefficient is 1. For sodium, the stoichiometric coefficient is 2. For sodium sulfate, it is 1 again. So for if it's 1, we don't write it. And for hydrogen, it is 1 as well. So this is your stoichiometric coefficient. The next thing is that in order for us to do material balance on a reactive system, we must first ensure that we have a valid stoichiometric equation. Meaning that a valid stoichiometric equation here is that it must be balanced. That is that the number of atoms on each of the atomic species must be same on both sides of the equation. Meaning that whatever you have on the left hand side, you must have on the right hand side. So if you look at this example here, we have sulfur dioxide. Okay, this is SO2. You add it with oxygen, they will react and form sulfur trioxide, SO3. Now, before we can start doing anything, the first thing that we have to do is that we have to make sure that the equation is balanced. Now, if you look at here, the way to do the balance of equation, I'm sure that you already know, but I'm just going to go through really quickly here with you. Okay, first of all, we must make sure that whatever S you have here must be the same number of S you have here. So this is you have one sulfur atom. So I can write here, I have one sulfur atom. And then on the right hand side, I also have one sulfur atom. So it is balanced between the left hand side and the right hand side. The next thing, right, I have here is I have 2 oxygen here because O2, meaning that O2 molecule has 2 oxygen atom. So I have 2 oxygen and I have another 2 here. So in total I have, so if I put here, I to have 4 number of oxygen atom here on the left hand side. But if I look at on my right hand side here, I only have 3 oxygen atom, meaning that this equation is not balanced. If it's not balanced, we could not proceed to the step for solving the material balance for this equation. So what we can do is that, since we know that it is not balanced, we have to try to make it balanced. One way to do that is that, since you know that S and S is already balanced, the easiest way for you to do is that you must do something to this oxygen. Okay, so that you don't disturb the S on the left hand side and on the right hand side. So if you see here, if I add here a stoichiometric coefficient of 1 over 2, okay, if I add a 1 over 2 or 0.5, okay, so 0.5 is here. So let's say if I add here 0.5, so what will happen to the oxygen there? So if I add 0.5 there, if I add 0.5 here, 0.5 times 2, I'll get 1 oxygen. Okay, so if I 0.5 times 1 is 0.5 times 2 is 1. So this one I have 2 plus 1 oxygen, meaning that I have a total of 3 oxygen now, which means that my equation is balanced because I have 1 sulfur on the left hand side, I have 1 sulfur on the right hand side, and I have 3 oxygen. Total oxygen is 3 on the left hand side and 3 on the right hand side, meaning that this equation is balanced. But sometimes we don't like to write 0.5, the stoichiometric coefficient. We usually like to write in a full number. So instead of having 0.5 here, let's say I put 1 here, okay, and to remove the 0.5, I can add here 2 here and 2 here. So if I add 2 here, what will happen to my sulfur? I'll have 2 sulfur on the left hand side and 2 sulfur on the right hand side. Here I'll have 2 times 2, I'll have 4 oxygen, plus 1 times 2 is still 2 oxygen, and then here 2 times 3, I'll have 6 oxygen. So here I have 6 oxygen and here I have 6 oxygen as well. So this equation is also balanced. So it depends on you whether you prefer to write 0.5 oxygen or you prefer to write 2 SO2 plus oxygen will get you 2 SO3. As long as the number of atoms are balanced, everything should be okay. So that is how we balance the equation. I hope everybody still remember. If you don't remember, please go back and do it on your own. So after we have balanced the equation, so let me just write the balanced equation here. This is 2 and this is 2. The next important thing we need to know is the stoichiometric ratio. The stoichiometric ratio of two molecular species participating in the reaction is the ratio of the stoichiometric coefficient in the balance. Okay, remember, okay, you must have a balanced reaction equation. This ratio can be used as a conversion factor to calculate the amount of a particular reactant or product. So that meaning that we must have the correct stoichiometric ratio, because this is one of the most important parameter that we'll be using in our mass balance. If your equation is not balanced, you'll get a wrong stoichiometric ratio. If you get the wrong stoichiometric ratio, you will do a wrong calculation on your material balance, and because of that, you'll get a wrong answer or your wrong data for your material balance. Okay, so that is why it is important for you to understand and do stoichiometry. So far, do you have any questions? Okay, so it is really easy. Okay, this is just a revision for you guys. I hope everybody is following me. So let's see an example here. So consider this reaction. We have here butane, okay, C4H8. This is our butane. Plus with oxygen, we'll get 4CO2 plus 4H2O molecules. So if we were to see here, we have 4 things that we need to make sure. The first thing is that, is this equation balanced? So how do you decide whether the equation is balanced or not? So you have to check each and every, you have to check each every atom in the equation. So first of all, let's say we look at carbon. So in carbon here we have 4 carbon, and then we have hydrogen, we have oxygen, and then we have 4 carbon on the right hand side. So meaning that I have 4 carbon on the left hand side and I have 4 carbon on the right hand side. So carbon, I know it is balanced. And then I have hydrogen, I have 8 here, right? So 8 hydrogen, I have 4 times 2, I have 8 hydrogen. So I know that hydrogen is also balanced. Then I go and I look at here, 6 times 2 is 12 oxygen. So I have 12 oxygen on the left. This one I have 4 times 2, I have 8 oxygen. And then here 4 times 1, I have 4 oxygen. So 8 times plus 4 is 12 oxygen. So my oxygen is also balanced. Meaning that, is this stoichiometric equation balanced? Yes, it is balanced. Okay, so you must be able to check and make sure you know how to balance the equation. The second thing is that, what is the stoichiometric coefficient of CO2? So CO2, you have it over here in your product. So if you look at here, the stoichiometric ratio is basically the number in front of your CO2 molecule, which is 4. So the answer here is going to be 4. That is your stoichiometric coefficient for your CO2. Now, the third one is that, what is the stoichiometric ratio of H2O to O2? And remember, unit is very, very important. So if you look at the ratio of H2O to O2, so you have here H2O is on the product side, O2 is on the reactant side. So if you were to write, the ratio will be, for H2O is going to be, let's say, 4 mole of H2O produced, okay, because it is on the product side, over 6 mole of O2 consumed. Okay, so this is your stoichiometric ratio between hydrogen, water, and also oxygen. And remember, you must be able to identify whether it's produced or consumed. This is important. That's why we say include the unit. The fourth one, the final one, is that we say that how much pound mole of O2 react to form 400 pound mole of CO2. So you want to know how much do we need, how much oxygen we need. So again, if you want to solve for this one, will you be using the stoichiometric ratio? So first of all, we have to know what is the stoichiometric ratio between CO2 and oxygen. So let's say I have my oxygen here. So I know that for oxygen, 6 pound mole of oxygen, pound mole of oxygen consumed right? Because it is on the reactant side, divided by the ratio of CO2 is 4 pound mole of CO2 produced. So this is my ratio. So why did I use pound mole? Pound mole because I was given the information in pound mole. Depending on the information given, so you can change from gram mole to pound mole. Okay. So now I want to find how much O2 will be consumed. So I know that in order for me, I know that I have 400 pound mole of CO2 produced. So this one, the unit will cancel out with this unit, and then 4 cancel out with 4, I get 100, and I'll get the value of 600 pound mole of H2O must be consumed. So that is how you use your stoichiometric ratio. So after this, when we are doing mass balance equation, you will do a lot of this stoichiometric ratio. Okay. So this is a few examples of equations. They might be balanced or they might not be balanced. It is up to you to decide. So if you like, you can go back home and try to solve and to balance this equation. So first of all, here we have C8H18 plus O2 will get you CO2 and H2O. This is actually the combustion reaction where this is your fuel, this is your oxygen, and you'll get CO2 and water. This is lead nitrate plus NaCl is your sodium chloride. Will get you sodium nitrate and lead chloride. Okay, this is your nitrogen plus oxygen will get you nitrogen dioxide. This is again combustion reaction, and this is also combustion reaction, but you should have here plus. Okay, so please go back and try to solve on your own, and hopefully you'll be able to balance on the equation. This equation might be balanced or might not be balanced. It's up to you to decide, and if it's not balanced, balance the equation. Okay, so let's say we look at this example equation. Okay, ethanol can be produced by fermenting glucose. So this is the formula for glucose. You have C6H12O6. Okay, and when you ferment the glucose, you will get this is ethanol, C2H5OH, and also CO2. Okay, so again, the stoichiometric ratio here is 1. The stoichiometric coefficient here is 2, and then 2. Okay, so based on this equation, we say that 1 mole, because we have one mole here, 1 mole will produce 2 mole plus 2 mole. Okay, meaning that 1 mole of the reacting material, which is our glucose, will produce 4 mole of product, which is 2 mole of ethanol and 2 mole of carbon dioxide. So you see here 1 mole will produce 4. Okay, and then if you look at, if let's say you have 180 gram of reactant, which is your 180 gram of your glucose, it will produce 180 gram of product, meaning that from that 180 gram, 92 gram will be ethanol and 88 gram will be carbon dioxide. So if let's say you say that you might not be sure about this, so you can go and try to get from 180 gram, you change to mole, and then you use your stoichiometric coefficient and the stoichiometric ratio to find the actual number of mole of ethanol produced and the number of mole of CO2 produced. After that, from mole, you get back to gram of ethanol and gram of CO2. So you will get 92 gram of ethanol and 88 gram of carbon dioxide. That is the second thing we can observe. The third thing is that you can see here the total number of 6 carbon, 12 hydrogen and 6 oxygen are same in both sides, right? Because we said that we can only do material balance on a balanced chemical equation. So you see here we have 6 here, and I have 2 times 2, 4, 4 times 4 plus 2 is 6, so it's 6 carbon. Hydrogen is 12 here, so I have here 2 times 5 is 10, and then 2 times 2, 2 times 1 is 2, so I have 12 hydrogen, and then oxygen I have 6, meaning that 2 times 2, 2 times 1 is 2, and then 2 times 2 is 4, so 4 plus 2 is 6. Okay, so the main idea that I would like to tell you is that the quantity that are conserved, okay, that are same on the left hand side and the right hand side are the total mass and total number of element, which is our carbon, hydrogen and oxygen. But our mole of reactant is not same as the mole of product. Okay, so this is a very important fundamental that you have to understand. In material balance, mole of reactant is not equal to mole of product, depending on your reaction. But always your mass will be equal and your number of atoms will be equal. So if you follow these rules, you will be able to solve any material balance problem.